Hey everyone, welcome to another lecture of probability, and today we are actually going to see the conditional probability. Okay, so what it is and how do we deal with the conditional probability, and it is one of the most, I would say, important thing in ML because we have to deal with many conditions in it. So let's get started with and let's understand what it is actually. Okay, so first of all, if you see that we have name in the name itself, we have a condition. Okay, so what is the condition in it? So in the conditional, we have some condition that we have to deal with it, and we have to find the probability based on that conditions. Okay, and the condition could be anything. Okay, it could be anything. Now, if you know, okay, let's suppose that we have an example. Okay, so suppose that you went to your school and you have been given your homework, and now you are doing your homework. Now we have two probabilities. Okay, this is the month of July. Okay, and we have two probabilities that it could be sunny outside or it could be cloudy outside. The weather outside could be sunny or cloudy. Sunny or cloudy. Okay. So if it is sunny, okay, if there is sun outside, then you won't stay at home. You won't stay at your home and you will go outside to play. But if it is raining, you will have to stay at your home and you will do your homework. Now, tell me by your common sense, then in which condition we have more chances to do our work, when you are outside your house or in your house, in your out. Yes, exactly. Cloudy. Because if you won't go outside, then you won't have any chance that you're not at your home, and you won't have any excuses that I wasn't at my home and I didn't do my homework, because because the weather condition of outside is not actually good. Okay, so you'll stay at your room, and the probability or the chances of doing your homework is higher if it is cloudy than the sunny. Okay, so that's what we deal here with. So in the conditional probability, we have some prior information that the tells the probability of the next event. Okay, and the next event. So we have a definition. What it says that sometime sometimes I would say that sometimes knowing prior information about an outcome can change the probability of the outcome. Okay, if you know the probability of some event, the previous event, then it could change the probability of the next outcome or the event. Okay, so in the conditional probability, we actually deal with the change that occurs. Sorry, that we deal with the changes that comes from the prior information. Okay, okay. So what in the conditional probability we actually deal with is that, let me tell you, the probability, okay, we actually say here is like that, the probability of an event, okay, given that another event has already occurred, okay, is a conditional probability. So what we are saying here actually that we have information that an event has already occurred, but what is the probability of an event occurring after the first event has occurred? Okay, now if we represent in the mathematical form, then it will be probability of A given B has already occurred. Okay, and remember that it is not actually dividing A by B. Okay, this, what should we call this? Let's say it pipe. Should we? Okay, yeah. For the so we are calling this. So we are calling this pipe. Okay, and this symbol means given. Okay, this means given. This is, I'm just saying it is a pipe, but this actually means given. So event A, given that B has already occurred, and it is not like that probability of A given probability of B. No, it's not like that. It is like probability of A given that B has already occurred. these both are very different thing. I don't think there would be anything like that, but it is actually the thing that we have to deal with. Okay, and it is not dividing. I'm again telling you. Okay, now we have some condition in it. So what are those condition? Okay, let us understand. Okay, so we let's do it by our own. Okay, so suppose I must know that you would be knowing about the cards. Yes, and don't tell me that you don't play it. I think I haven't even played it, but if I played, my parents would even sorry. So suppose in the cards, if you know that we have actually two colors. Okay, the first one is black and the another one is red. Okay, and in the black we have two groups. Okay, I would say groups. The first one is a spade and the second one is club. Okay, now we have in the red we have also two groups, heart and diamond. Okay, now in the each group in the each group okay, in the each group we have 13 cards. Okay, 13 cards, and these card contains a king, a queen, a jack, an ace, and number from 2 to 10. From 2 to 10. So these three and these 10. A is 1. Okay, A is 1. So we have 13 card, and in each group we have king. Okay, if I move it from here, we have king, queen, jack, and number till 10. Same in this, king, queen, jack, number till 10. King, queen, jack, number till 10. Again, king, queen, jack, number till 10. Obviously, yeah. And this has 13, this has 13, this has 13, and this has 13. So if we sum it all, it will be 52. So in the cards, we have 52 cards. Okay, and the 52 cards are distributed like this: four groups, 13 card each, and each card. Okay, and each group has a king, a queen, a jack, and a number from 1 to 10. Okay, yeah, this is like this. Now, suppose that you're playing a card. Just suppose, you don't have to. You're playing a card, and you have to actually find that what is the probability, okay, of getting a black card which is a 4. Okay, black card which is a 4. Okay, so you have to get a card which is black and also 4. Also 4. So if we do it by your own, okay, by our, actually, as we have learned the probability, then it will be, we have total 26 cards. Okay, 26 cards of red and 26 cards of black. Okay, so we have black 26 and red 26. Now what card do we want? We want actually black card, so we will eliminate our red card. How many card did we have? 52. Now we have only dealing with this, so we have only 26 cards. Okay, we have only 26 cards. Now in the 26 cards of black, okay, we have two groups. We have two groups, spade and club. And spade, in the spade, what we have? King, queen, jack, and numbered from 1 to 10. Then we would have number 4 somewhere here. Okay, and for the same, okay, king, queen, jack, and 1 till 10. Then we would have 4 somewhere here. Okay, so if you see, then we have in the 26 cards, we have 2 4s. Okay, 2 4s. Now, is this condition satisfying? Are these two 4s satisfying our condition? What was our condition? It should be black and 4. It should be black and 4. Yes, definitely they are satisfying our condition. They are satisfying our condition. Okay. So what its probability would be? So the probability, oh sorry, the probability of a card should be a black and 4. Okay, this means and 4 at this 2 by 52 because we have only two cards that are black and 4. So 26. So in the 26 card we have only one chance that it will be black. So this is our own way. This was our own way. But this leads to a mathematical formula. Okay, that is probability of A given B equal to the probability of A intersection B by the probability of B. So this is the mathematical formula for finding the conditional probability or to find any probability that has condition. Okay. Now what it tells us actually. Okay. So this thing A given B. Okay. This is the pipe or the symbol that tells us yes, it is given. Now it tells us that A given B. You have to understand it. A given B, which says B has already occurred. B has already occurred, and we have to find probability of A after B after B. So what it will be like, what we want to say here actually that if we understand with our previous example, then what is the probability of getting a card which has a number 4 given that all the black card has occurred. Okay, so what it says that in the 52 cards we have only black cards that has been drawn. Okay, now in the 52 cards only black has been occurred. Now in the black cards, what is the probability that we will get 4? We will get 4. So which leads to by telling us that A and B. So what it says that probability of 4 and black. What is the probability of 4 and black? Getting 4 and black. We have got this. Okay. 1 by 50, 1 by 26. Did we? Yeah, obviously. Okay. Now, now, okay. Now, wait. Yeah. What is the, okay. What is the probability that, what is the probability of getting a black card? What is the probability of getting a black card? So it will be nothing but 26 by 52. Getting a black card, it is 26 by 52. Okay, which will be 1 by 2. Which will be 1 by 2. Okay, which will be 1 by 2. So if we put this here, then it is 1 by 26 and probability of 1 by 2. Okay, and if we do the our simplification, then it will be 2 and 1. It will be 1 by 13. It will be 1 by 13. Okay, now what does it tell us? It tells us when, okay, we need to understand this, that when we drawn all the cards, okay, only black were there. So what happened actually that we had a sample space. Okay, now we had 26 cards of reds, 26 cards of black. Okay, this was our whole sample space. This was our whole sample space. Now what if we have to find the probability of getting B, which is black? What is the probability of getting a black? 26 by 52. 26 by 52. Okay, so 1 by 2. This is the probability that we got for getting the black card. Now, if we want to find the black and 4, what? Black and 4, then it will be, what it will be? It will be nothing. Okay, sorry, not nothing. I was just scrolling in my app things. So, when an event has occurred, suppose that B has occurred, okay, or the black cards has been occurred, the sample space gets reduced. The sample space gets reduced. When we said 4 and B black, then we are only talking about the 26 cards. Forget the 52 cards. We are eliminating 26 cards. We are eliminating 26 cards. Okay, which is what? Which is red. Okay, which is actually red. Now, if which is actually red. Okay, so if we want to find the probability of the second event, okay, probability, then the sample space for this event will only will reduce to B. Okay, why? Because this event is inside the B event. Once if B will occur, then the probability of A will matter. Okay, suppose it is like this. Okay, we had a box in which we have 26 reds, and in the 26, in between 26 blacks, we have two fours. We have two fours. So if we want to find the uh, two four blacks, okay, then we won't find in the reds. We will only find in the blacks. Okay, that is why the sample space get reduced to that event. And what the sample space will be? The event that itself that has been occurred. Okay, so what will be I'm telling you, A given B. Okay, so the sample space of getting A will be the event B. Okay, okay, so what I'm trying to say is that we have a event A here, and this is the event B. So if we draw the circle, then this is the fifth. Oh wait, where the, oh again, I can do it again. So we have this 52 cards. Okay, we have this 26 cards, and in between we have an event which has two four blacks. Okay, now what was for 26? We have 52. We have the sample space of 52, and for getting the two black cards, we have the sample space for 26. So it reduces, the sample space get reduces. That's why the probability of A matters, and it changes with the prior information of probability of B. Okay, the probability of P. I hope you would be understanding. Let's understand with then another example of dice. Okay, of the dice. So say that in 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 the dice, okay, what are the possible outcomes? The die is a 5. Okay, and we have another event C. Okay, C, which says the die is odd. The die is odd. Now if you put in the formula, then what we have to find? We have to find A given B. A given B, which is nothing but what is the probability of getting 5 if all the odds has been occurred. All the odds has occurred. So it will be A, find it one by. What is the intersection C? die is 5, then it will only contain 5. Now if the C, what is C? Okay, C says that the die is odd. The die is odd. 2 man, 1 3 5. Okay, and what is the intersection of this? Nothing but 5. Okay, now what is the probability of getting 5? So this says that what is the probability of getting 5, which is nothing but 1 by 6. Yes, it is 1 by 6. Okay, now what is the probability of getting C? Now what is C here? C is that 1 3 or 5, which is odd. It's nothing but 3 by 6, because we have three favorable outcome that we want, and dividing by the all the possible outcome, which is 1 by 2. Now if you put in the formula, probability of A intersection C by the probability of C, it will be 1 by 6 divided by 1 by 2. Okay, now 1 by 6, if we do the simplification, 1 by 2 by 1, which will be 1 by 3. So probability of die is 5 given die is odd, okay, is 1 by 3. And as I said, that the sample space get reduced. How it reduced? So first it was 6, okay, and we forgot the 2 4 and 6. We only, that matters to us was 1 3 5, because we have to find the odd numbers, and if we want to find the odd number, then we have to choose this, not this, because we don't have the 5 in it. Okay, so what we did, that sample space get reduced to 3. How? Not 6, because in the 6 we have 2 4 6 also, but we have to only find that is 5. And what we have been given, that we have been given that the die is the odd, so we chose this, which is 3 outcome, and in the 3 we have a one number which is a 5. That is why it is 1 by 3. In the 3 we have only one number, that is 5, and that is what it says, and that what it says. Okay, so the conditional probability, I hope that you would be you would have no any problem, and any doubt if you have, you can ask me in the comment, or you can go and check our Discord. You'll find more enthusiasts about AI there. So yeah, thank you for watching right now. Bye bye.